We are now going to connect in our ZVS to our Tesla coil. I just did a video on how this actually goes together. So now we're going to look at this. This is the way we want it oriented, right here. Now, this is the negative on this side. This is the positive on this side. We simply have our power source right here, and we're going to connect that in. So the white wire here is coming out of our negative. The black wires are positive. You'll notice right here on my negative, I have a switch. Now it's pretty simple. You can use whatever switch you want. We're not going more than 40 volts, so an AC switch or a switch like this on DC would work just fine. So let's look at how we connect that in. And I'll just do it here for you. Now, a lot of this stuff, if you're going to do it, you may want to get the little crimp things. I like to solder the crimps on. I hate when things fall out. I'm sure a lot of you do. Again, we said our black wire was positive. We'll get that put in here. And then our white wire was the negative. Make sure you get it in there. And then I just like to turn it up like this. So now positive, negative, just turn it on and off. So we're good there. Pretty simple. Now, how do we hook in our Tesla coil? This is our Tesla coil here. And all we want to do is run the two wires. Again, you see this one here to the bottom. This one here clips on to where you want to find resonance at. So always, and I mean always, the right side, when you look at this, in this exact configuration, you're going to have this side go into here. So we'll simply take that, put it into there. So go right into here. Now we're going to take the other side. I should probably take out this screw first. Now that's connected in there. Let's just take a closer look at it. It's simple, it's set up. We have our capacitors changed. This side right here always goes to the bottom of our Tesla coil right here. This side right here always goes to the clip that goes on for our Tesla coil. Now, later on you'll be able to take this out and put it on a different clip, however you want to do it. I personally use mine for science, so I move it up and down and change a bunch of different stuff on my Tesla coil. So I tend to leave it there. Now, this right here is my negative wire, or excuse me, it goes right to my number 2. So it's the ground. And it goes off, and we're connected right here, just into here. Now, before I plugged it in, the positive and negative were both wire capped and taped. I like to be safe on that. See the little wire cap or wire nut, if you want to call it that. And that's it. That's grounding for your Tesla coil. It goes to the number 2. So, now this right here goes to my oscilloscope, and then I have my power unit. Okay, with that said, we are now going to turn everything on. Make sure that our power source is down to 0. Let's see, as everything starts up, I simply want to move this right around like 10 volts. 11 volts is fine. And then we're going to go over here and we're going to turn on our switch. Now, I should say this. Before that switch is on, make sure that clip is on there. Very, very important. Do not just have it dangling in the wind. Make sure it's clipped on. Wherever it's clipped on is the first place you start. So, we have it here. Our oscilloscope is on. And all I have to do, I can move this over just a hair. I generally just put a little box here, and that's my oscilloscope wire. Pretty simple. The box here, just keep it away from the ZVS. Also, I need the height to be about equal right over in this area so that I can get the resonance frequency. This right here is just a little wire stick on the end. You don't necessarily have to have anything in particular. Just put a wire there so that it can pick up the signal like it's an antenna between the two. Now, we're going to turn it on. Then we're going to go and look at our oscilloscope. That right there is a terrible first reading. I could tell you that just by looking at it, we're out of resonance. So we'll turn it off. Come back over here and look at our clip and go, okay, something's off. Now we're just going to move it. Turn it back on. Same look, out of resonance. Turn it off. Now this process is going to go on for a while. So you exactly know where your resonance point is. You're going to have to keep moving it. So we'll go up one. Turn it back on. And that's even worse. I don't even have to do a numbers readout, guys. I could tell you it's worse just by looking at it. So we go again. And that's still bad. So, let's go to the other end of the spectrum over here. And that's still bad. Okay, well, it's going to take us a minute to get this thing in resonance, but we got time. So one thing you don't want to do, make sure it's off before you move that clip. Never try to move the clip when it's on, because these MOSFETs right here, these things will fry. There's no question about it. That's what they're going to do. Don't try it unless you want to fry it and find out. I have done. Now we got a good signal. So let's take a look at this. I'm simply going to move it from one to the next. So I'm going to turn it back off. I'm going to move it up one. On the rings, bad. That's horrible. There we go. That's a signal you can work with. So now we're right around 497. That's pretty close to 500. That's about where this Tesla coil right here is going to resonate. So let's take a look at it again. Let's see where we ended up. So look where that clip is. Now this is the importance of tuning your Tesla coil like this. Now I know where it is. I can simply take a marker and mark it on both sides of that and then put on a permanent clip. That's it. Then we hook it back up the wire the same way. We're good to go. Now, what do I like to do? Always a fiddler. we're just going to turn it off again. Move it slightly a bit over. And turn it on again. Now, what am I looking for when I just did that? So my oscilloscope still reads the same thing. Basically, what I'm looking for right now is a drop-off point. I want to find the point where it goes off and makes a bad signal, and then I want to find out where it makes a good signal. That is the point you want to be at for the absolute best tuning on a Tesla coil. I almost got it a Tesla coil. And we're still good there. So we'll continue to do that and we'll find it. Let's see if I can't just give you a better picture of this as I do it. Now, on a general basis, you do not want to run these things cross over each other. Make sure they're not touching each other. Send off your reading altogether. Yeah, we're still good. And by the way, every time you move it, any adjustment that you make, this board moves, this thing moves, whatever it is, it's going to throw off your resonance signature. Every time. The more connected it is and non-movable it is, the better. So if you put this here onto a board, connect it, put this onto a board, and make sure this secondary, or excuse me, this primary is connected in here in some way so it doesn't move. That's where you want to be. Again, mine's for testing purposes, so I don't have that, but you're going to be much better off doing that. So we're not finding it there. I'm not going to extend that wire. I got a good resonance signature. Ooh, and I found a bad one. Okay, maybe I'm just too low. Yeah, not low enough. Sorry. That right there is getting close to the edge. How do I know that? Do you see how it's moving when I put my hand close to it? You see the oscilloscope. Watch. I know that we're close to the edge because my body capacitance is setting it off. So it's got to be right close to there. So I'm going to go ahead and call that good. I'll move it back just a hair to keep a steady signal. And now we are good to go. So I'm going to go get a light bulb and just show you that it lights up. And there you are, a nice light up. Now, what is the general distance? So we are at 11.4 volts. On this ZVS, I am right now about 30 inches away, and you can see the lights lit up. That's a ZVS Tesla coil. We didn't bring it up any, we're still at 11.4 volts. So that's a pretty good distance for that. That's why I use this. So let me set down the light. And we'll just take a look now. 11.4 volts. The ZVS is connected and it's on. Right there, that's where we ended on our clip on this particular Tesla coil. Sorry, I just hit the thing. Right there is where we're resonating at for this Tesla coil. That's pretty much it. That's how you set it up. It's a simple, easy way to connect a ZVS driver. So let me turn it off and I'll just go over a couple things for you. This wire here always goes to the bottom here. This wire here always goes to your clip. There's no changing that. This wire here connects to your number 2 coil, which is the big one. And that simply goes to the grounding here. Right in there, the only plug we're using in there is the ground. The hot and the cold are, again, wire nutted off, and they're taped for safety. That's it. Those are your connections on a ZVS Tesla coil. It's easy as can be. Doesn't take very long to do. But once you set this up, you're good. Now, let's just talk about frequency for a minute. The frequency, in a general case, 290 to right around 500. I tend to set my Tesla coils at 300 when I build them. This particular Tesla coil I built to do in the 500s. So as we saw right here, we're resonating right close to 500. As easy as it gets. And now we have our ZVS Tesla coil connected and we're ready for testing for the day.